When we think of gold, our minds often drift to images of vaults. Fort Knox, with its legendary security, comes to mind. Gold is a symbol of immense wealth, adorning luxury items and high-value assets. Fort Knox holds tons of gold bullion, a testament to its value. Protected by thick walls and steel doors, it's a fortress of wealth. It seems like the ultimate treasure chest, a dream for many, a place where a nation's fortune is kept safe and secure. But what if the greatest gold reserve isn't in a vault at all? What if it's not even man-made, but a natural wonder? Imagine a treasure far larger than any vault could hold. A hoard of gold beyond our wildest dreams, hidden from sight, not locked away by people, but by nature itself, held deep within our own planet in places we can barely reach. This idea might change how we see Earth and its hidden treasures. It suggests a different kind of richness, one that is natural and ancient, one that has been hidden from us for eons, waiting to be discovered. Our planet Earth is a complex place with many layers and secrets, like an onion, but much hotter and more mysterious. The part we live on is just the crust, a thin layer on the surface. Beneath it lies the mantle, a vast and dynamic region. And deeper still, the core, a place of intense heat and pressure, a mysterious and fiery realm holding secrets we are only beginning to understand. Scientists are like detectives. They look for clues, they try to understand the universe, and sometimes they find something amazing, something that changes everything. Researchers at Göttingen University in Germany. They have made such a discovery. It concerns the Earth's core and its hidden, glittering secrets. Their findings are truly remarkable. They suggest Earth's core is leaking, not water or oil, but something far more precious. The core is slowly releasing gold. Yes, actual gold, along with other valuable metals. This isn't science fiction. This is based on careful study, using advanced scientific methods. Imagine that fiery heart of our planet, gently sharing its golden wealth. With the layers above it, this idea is quite new. It challenges old notions. For a long time, we thought the core was separate. How can scientists know what is in the core? We cannot drill that deep. The pressure and temperature are too extreme. Our best drills barely scratch the surface. So researchers look for indirect evidence. They study materials that come from deep within. Volcanic rocks are perfect for this. They are messengers from the Earth's interior, carrying secrets from below. Researchers use very precise methods. They analyze volcanic rocks. These rocks originated from deep in the mantle. Some even show signs of interacting with the core. The scientists looked for tiny traces of precious metals like gold, platinum, and others. They needed incredible accuracy to detect such small amounts. It is like finding a single grain of sand on a very large beach. The study focused on specific types of volcanic rocks, those found in places like Hawaii. To prove this core leakage, scientists needed a clear signal, a sort of fingerprint, something unique to the core. They found it in an element called ruthenium. Specifically, they looked at its isotopes. Isotopes are different forms of the same element. They have the same number of protons, but a different number of neutrons. This makes their atomic weight slightly different. The Earth's core is believed to have a special mix, a high abundance of a particular ruthenium isotope. This isotope is called 100 Ru. That is ruthenium with an atomic weight of 100. This specific isotope is rare in the mantle, but thought to be more common in the core. If 100 Ru was found in mantle-derived rocks, it would be strong evidence. Evidence of material moving from the core. New ultra-high precision methods were key. These methods allowed the researchers. Section 5. Challenging old beliefs. A core revelation. This discovery is more than just about gold. It changes our fundamental understanding, our understanding of the Earth's core. Professor Matthias Wilbold, also from Göttingen University, explained this. He stated that these findings are significant. They challenge previous assumptions about how our planet works, deep down inside its hidden layers. For a long time, the core was seen as isolated, a giant ball of iron and nickel, mostly separate from the mantle above it. It was thought that very little material could cross the boundary between them. The core formed early in Earth's history, and its composition was thought to be locked in. But this new research suggests otherwise. It shows a more dynamic interaction. Section 6. From core to crust, the journey of precious metals. So how does this material travel? From the core, thousands of kilometers below, all the way to the surface. It is a long and complex journey. The core itself is mostly liquid iron and nickel. The mantle is solid rock, but it can flow very slowly, like thick honey, over millions and millions of years. This slow flow is called convection, similar to water boiling in a pot, but much slower. Dr. Niels Messling's work helps us understand. He confirmed that gold from the core is making its way into the mantle. This happens at the core-mantle boundary, a region of extreme conditions. Here, some core material might mix with the lowermost part of the mantle. This enriched mantle material can then get caught up in rising mantle plumes. These plumes are like hot elevators. Section 7, Beyond Gold, a treasure trove of elements. While gold captures the imagination, it is not the only precious metal that might be leaking from the core. The study suggests a richer bounty. Other valuable elements could also be on the move. This makes the Earth's core an even more fascinating chemical reservoir, a hidden source of diverse materials waiting to be understood by science. The research team mentioned other metals like palladium and rhodium, and the ever-valuable platinum. These are part of the platinum group elements. They are rare and highly prized for their unique properties and uses in catalysts, electronics, and jewelry. If these are also seeping from the core, it adds another layer to the discovery. Section 8, Meteors and Mantle, Rethinking Our Metal Origins. For a long time, there was a dominant theory about where Earth's accessible precious metals came from. This theory has shaped our understanding of Earth's geological history and the distribution of valuable resources. Scientists believe they were delivered by meteors. These meteors, traveling through space, carried with them a treasure trove of metals. This was called the late veneer theory. It posited that after the Earth had formed and its core had separated, a bombardment of meteors and comets enriched the planet's outer layers with precious metals. After the Earth formed and its core separated, the early Earth was bombarded by asteroids and comets. These impacts were not just catastrophic events, but also delivery systems for metals. These celestial bodies carried metals, including gold and platinum. These metals, which are highly sought after today, were deposited into the Earth's mantle and crust. These meteor impacts, it was thought, added these precious metals to Earth's mantle and crust after the core had already formed. This theory explained the presence of these metals in the upper layers of the Earth. This explained why these metals are found closer to the surface rather than all being locked deep in the core. The late veneer theory provided a neat and tidy explanation for this distribution. Because these metals love iron, they should have mostly sunk into the core during Earth's initial differentiation. However, the late veneer theory suggested that the metals we find today were added later. The late veneer was a neat explanation. It fit well with the evidence available at the time and provided a coherent narrative for the presence of precious metals in the Earth's crust. This new study from Göttingen University does not necessarily overturn the meteor theory completely, but it does offer an additional source. It suggests that our understanding of metal origins might be more complex than previously thought. It suggests that some of the gold and other precious metals we find might actually originate from the core itself, leaking out slowly over geological time. This new perspective opens up exciting possibilities for future research and exploration. Section 9, The Slow Leak and Future Quests, Unlocking Earth's Deepest Secrets. So, does this mean a new gold rush is coming? Are we on the brink of discovering untold riches beneath our feet? Can we drill down to the core and tap into this immense reservoir? The idea is tantalizing, but the reality is far more complex. The short answer is, unfortunately, no. The challenges are monumental and currently insurmountable. The emergence rate of these metals is very slow, extremely slow. We're talking about processes that take eons to unfold. We are talking about geological timescales, millions of years for tiny amounts to surface. This is a slow dance of nature, not a quick sprint. This is not a get-rich-quick scheme from Mother Earth. The treasures of the deep are locked away, far beyond our current reach. Furthermore, drilling to the core is currently unfeasible. The technology required is beyond our present capabilities. It remains firmly in the realm of science fiction. The vision is there, but the means are not. The Earth's core is thousands of kilometers deep. Reaching it is a journey of unimaginable scale. The pressures are millions of times atmospheric pressure. Such extreme conditions are beyond our current engineering solutions. The temperatures are as hot as the sun's surface. No known material could withstand such conditions. No known material could withstand such conditions. Our current technology simply isn't up to the task. Our technology is far from ready for such an ambitious journey. We are still in the early stages of understanding these extreme environments. We must rely on these indirect clues. They are our windows into the deep, revealing secrets that direct exploration cannot. The true significance of this research lies in understanding our planet. Each discovery adds a piece to the puzzle of Earth's history. It deepens our knowledge of Earth's formation, its evolution, and its internal dynamics. This is the story of our planet, written in stone. It shows that Earth is a living, breathing planet, even in its deepest, most mysterious regions. The planet is alive, constantly changing and evolving. These findings will spur more research. Each new piece of data drives scientists to ask new questions and seek new answers. Scientists will look for more evidence in other volcanic regions around the world. These hotspots are key to unlocking further secrets. They will refine their models of how the core and mantle interact.